Hello students, welcome to our today's interaction. In this today's interaction, we are going to identify whether the given compounds are aromatic or anti-aromatic or non-aromatic. So before going to find out, just we need to revise that rules for that aromatic, anti-aromatic. Just you people are know very well, it must be a cyclic, planar and conjugated system, and it should have 4n plus 2 pi electrons or delocalized electrons. That is called aromatic compound. Anti-aromatic compound means same thing, cyclic, planar, conjugated system it should have, and 4n pi electrons or delocalized electrons it should contain. So I think you may ask one question here, what about non-aromatic? Non-aromatic means above whatever we discussed, those conditions, if anything is not satisfied, then that compound will come under non-aromatic. Okay, so now we will check. So coming to the first example, you take this first example. So in that first example, center they gave one circle and plus 2. What is the meaning of that? First you should have clarity on it. Circle means delocalization is taking place and this compound is having two positive charges. So therefore, this structure you can also write like this. How? Like this you can write. Here I am taking one pi bond and here one positive charge I am taking. Here one positive charge I am taking. So therefore, here how many delocalized electrons are there? First you count. How many delocalized electrons are there? 2 pi electrons are involving in the delocalization. 2 pi electrons means n value is how much? 0. You know very well. 4n plus 2 pi electrons if you take, in n place if you take 0, 2 pi electrons should be. So it is satisfying the 𝐜𝐸 rule, which is related to aromatic. And one more thing, here you see this. Is it involving the delocalization and is it planar? Yes, obviously it is a cyclic, you know very well about that. And it is a planar because all, carbon atoms in this sp2 hybridization they are involving, and they are conjugation also, involving in the conjugation. What is that? How is that conjugation? You check it once. Here, this pair is coming here. So automatically negative charge. In between these two, pi bond will come, and here positive charge will come. Like that, pi bond keep on moving. So therefore, it is satisfying the all rules which are related to the aromatic. So that's why we can say the first compound is what here? Aromatic. Okay, first one is aromatic. Coming to the second one also you can write as like circle is there, that means delocalization of pi electrons are taking place and one positive charge is there. Now you check it here whether it is aromatic or not, you can get it clearly. So this structure I am writing like this. Here I am taking one positive charge and here pi electrons. Now here, is it satisfying 𝐜𝐸 rule? Yes, definitely it is satisfying the 𝐜𝐸 rule because n value 0 if you take in 4n plus 2, how many pi electrons should be, or delocalized electron should be 2. So it is having 2. Here it is having 2 pi electrons or 2 delocalized electrons. Now in each carbon atom in this triangle, automatically sp2 hybridization, and they are involving in the conjugation. See, they are involving in the conjugation. How? This pair is coming to here. It gains positive charge. It gains negative charge. And these two will form bond. Have you got it what I am talking? These two will form bond. So that means again, that pi electrons keep on shifting. That means they are involving in the delocalization. So therefore it is a cyclic compound and it's planar and it is involving in the conjugation and it's satisfying 𝐜𝐸 rule. Confidently we can say that second compound is aromatic compound. Okay, so right. So first one is aromatic and second one also aromatic. Well and good. Now coming to the third one. So what is third one? Is it aromatic or non-aromatic or anti-aromatic? We need to check about this. Here you see here, how many pi electrons are there here? 2 pi electrons, we can say that. And here the charge is negative charge. Negative charge means lone pair is there. So that lone pair electrons also involve. So therefore there are 2 electrons and here 2 electrons, total 4 delocalized electrons. So here it is a cyclic. We know very well about it. And here how many electrons are there? Delocalized electrons. How many? 4 electrons are there. 2 belongs to pi and 2 belongs to that pair which is present on that negative charge, or in terms of negative charge on the carbon. Now total 4 electrons. That means it is not satisfying the Huckel's rule. It is satisfying 4n pi electrons rule. Okay, done. It is cyclic. Is it involving in the conjugation? Once we check it. Okay, or delocalization. You see this? It is a conjugated. Is it involving in the delocalization or not? Once we have to check it. See this. Here it is moving. Here it is getting negative charge and positive charge. In between these two, pi bond may exist. Here negative charge will come. That means it is satisfying C cyclic, planar and conjugated, but it is not satisfying Huckel rule, which is 4n plus 2 pi electron. It is satisfying 4n pi electrons. That means it is a anti-aromatic compound. Okay, anti-aromatic compound. Now coming to the next example. Fourth example is general IUPAC name is cyclooctatetrene. Cyclooctatetrene. Simple way it is called as COT. Okay, COT it is called. So general name is there. Like this type of compounds are having general name. That general name is called as anulins. Anulin. Anulin means what, sir? What is meant by anulin? So if a single cycle which contains alternative double bond and which is more than 6 carbon atoms, generally we call it as like a anulins. Anulins means you have to keep it in your mind. It is a single cycle and that cycle is having alternative double bonds. Then that type of compounds we can call it as like a anulins. It is an anulin, but actually coming to the IUPAC name, it is cyclooctatetrene. So now we have to check it whether it is aromatic or anti-aromatic or non-aromatic. Here one of the important point is there, and it is one exceptional case point. You need to have clarity in this. You see, it is a cyclic compound, you know very well. It is having conjugation and delocalized electrons. How many are there? So you see this here, 8 pi electrons or delocalized electrons are there, because four pi bonds are there. Each pi bond is having 2 electrons. 8 pi electrons are there. 8 pi electrons means you may get one doubt. So whether it is Huckel rule or 4n pi electrons. It is a 4n pi electrons. How can I say? You take 4n, okay, pi electrons rule. So in n place 2 substitute. How many electrons will come? 8 pi electrons. 8 pi electrons means what? Anti-aromatic. But you need to have clarity here. It is not in planar structure. It is cyclic. I agree with you. It is having conjugation. I will agree with you. And it is having 4n pi electrons, which is equal to 8 pi electrons. I will agree with you. But it appears like they gave it as like a conjugated, or they gave it as like a one ring, like first one. But actually it is existing as like tub shape, which is non-planar. Okay, it is not a planar. You keep it in your mind. For stability point of view, the cycle which is given starting this one will be converted into tub shape, which is non-planar. So therefore, don't tick it. It is anti-aromatic. No. It is a non-aromatic compound. How can I say it is non-aromatic compound? Because out of those rules which we have learned for cyclic, okay, planar, conjugated and 4n pi electrons are delocalized electrons. Out of these 4, if any one is not satisfied, it will come under non-aromatic. I already told you in the starting of this video. So it is not a planar structure. It is a non-planar. So non-planar means it never considered as like a anti-aromatic. It is considered as like a non-aromatic. Is it clear, dear? Now coming to the fifth example. You see this fifth example. It is also coming under anulins. Anulins means it's one cycle. Okay. And here alternative double bonds are there. Single cycle and alternative double bond. It is considered as like a anulins. So right. Now we have to check it. Whether it is what aromatic, anti-aromatic or non-aromatic? Very simple dear, it is a planar structure only, not like above example. You keep it in your mind, it is a planar structure. Okay, so planar structure and it is a cycle, planar and it is having conjugation. And how many pi electrons are there once you check? Total here 2, 4, 6, 8, 10, 12. So 12 pi electrons are there. How many? 12 pi electrons are there. 12 pi electrons means it's 4n plus 2 pi electron or 4n electrons? 4n electrons. 4n electrons means here 4n electrons, pi electrons. So if you take 4n means n value should be taken how much dear, tell me? Yes, that is n is equal to 3. So here this compound coming under anti-aromatic. Okay, right. Coming to the last example, you check it, how many pi electrons are there? First, clarity point of view I am saying, how many pi electrons are there? Yes, it is having 10 pi electrons or 10 delocalized electrons. 10 means what? In 4n plus 2 pi electrons, if you substitute n is equal to 2. Okay, n is equal to 2 means what? 2 into 4, 8 plus 2, 10 electrons. So it is satisfying Haeckel rule up to here. Okay, now coming to the, is it cyclic? Yes, obviously it is cyclic. We don't have any doubt. Is it having conjugation? Yeah. Is it having delocalization? Yes, it is having delocalization. We agree with that also. But coming to the point here, is it having planar structure or not? No, it is not having planar structure. How can I say it is not having planar structure? Because the hydrogens which are coming out, they repel with each other, and due to that repulsion, the shape of the ring will be changed to planar to non-planar. So that's what is happening due to it is satisfying all. What Haeckel rule is satisfying, and next one conjugation and single ring, but it is not a planar. Due to that, it is coming under which category? Non-aromatic compound. Have you got it dear? It is a non-aromatic compound. Is it clear? So complete video about these rules and regulations I made it. Okay, that video link also I will give in this video description. Okay, use it and you try to get clarity on this aromatic compound, non-aromatic and anti-aromatic. Okay, thanks for watching. Bye bye.